What is electromagnetic compatibility? Electromagnetic compatibility, or EMS, means that an electronic device can operate properly without emitting unwanted signals and without being affected by other devices' signals. In other words, it ensures devices can work together in the same environment without interference. This is essential for the reliable and safe operation of modern electronic systems. What is EMI and why is it dangerous? EMI stands for electromagnetic interference. It refers to unwanted electromagnetic signals that disrupt the operation of electronic devices. For example, a radio signal causing noise in a speaker or a motor interfering with a sensor. EMI can reduce performance, cause data loss, or even system failures, which can be very dangerous in airplanes, hospitals, or industrial environments. Why is EMS important? With the growing number of electronic devices, the risk of interference has also increased. Poor EMS can lead to expensive malfunctions or safety issues. That's why EMS is now a legal requirement in many countries. For example, CE in Europe or FCC in the US. In critical areas like aerospace or healthcare, EMS compliance is mandatory. Difference between EMS and EMI. EMS means compatibility, working without causing or receiving interference. EMI is the opposite, it's the interference itself. A good design aims to maximize EMS and minimize EMI. So in summary, EMS is the goal, EMI is the problem.
Classification of EMI sources. Unwanted electromagnetic energy that disrupts the normal operation of electronic systems. EMI sources are categorized into two main types. Natural sources, lightning, solar flares, electrostatic discharges. Man-made sources, electric motors, switch mode power supplies, radio transmitters, computers. That's it. Not AMI can be generated internally or externally. İlerle. Types of AMI by physical propagation. AMI can be classified based on how it propagates. Conducted AMI travels through physical conductors such as power cables and signal lines, dominate at low frequencies. Radiated AMI spreads through the air as electromagnetic waves. Components or cables may act like antennas, dominate at high frequencies. Types of AMI by source. AMI can also be defined by where it originated. Internal AMI occurs within the same device. Example, the switching noise of a power supply affecting a sensitive signal circuits. External AMI comes from other devices or systems in the environment. Example, base station, microwave ovens, hair dryers. Mitigation strategies. Internal AMI minimized through careful circuit design. External AMI reduced using shielding, filtering, and grounding techniques. Sector-specific examples. Examples of AMI impacts in different industries. Alternative ignition systems can interfere with vehicle sensors and electronic control units. Healthcare devices like magnetic resonance imaging and electrocardiogram are highly sensitive to AMI. External AMI can cause incorrect readings or diagnosis. Telecommunication AMI can lead to interferences between transmitters and receivers. result in data loss or communication breakdown.
In this part, I will briefly talk about some important EMC practices: filtering, grounding, and shielding, PCB design rules, device enclosures, and related standards. Let's begin with filtering. In electronic circuits, filtering helps remove unwanted noise. We often use capacitors, inductors, and ferrite beads. For example, a capacitor between power and ground can remove high-frequency noise. A ferrite bead on a cable can stop noise from going out or coming in. They are very common in power lines and signal pads. In the next part, grounding and shielding. Grounding gives a safe path for unwanted signals to go to ground. This helps reduce EMI. Shielding uses metal cases or coverings around cables to block outside interference. It works like a Faraday cage, stopping signals from going in or out. In the last part, PCB design rules. A good PCB layout is very important for EMC. We use ground planes, place decoupling capacitors close to chips, and keep high-speed signal paths short. Analog and digital parts should be separated to avoid interference.
EMC testing and applications. EMC testing checks if electronic device can work properly without creating problems for other devices, and also if they can keep working when there is electromagnetic noise around them. This is very important today because we use many electronic devices close to each other. Types of EMC tests. There are two main types of EMC testing. The first one is emission testing. This test looks at how much unwanted electromagnetic energy a device gives off. If it gives off too much, it can disturb other devices. The second one is immunity testing, which checks if a device can keep working when it's near other devices that make electromagnetic noises. EMC applications. EMC testing is used in many industries. In healthcare, medical machines like heart monitors must not stop working because of interference. In cars, many electronic parts must work together safely. Airplanes, mobile phones, and even home appliances also need EMC testing. EMC test organizations. Before a product can be sold in most countries, it must pass EMC test. Organizations like the FCC in the US and CE in Europe checks that device follows the rules. This helps protect people and make sure products are safe, reliable, and work well with others. In short, EMC testing help us live in a world full of technology without problems or danger.